Let's sort 5, 1, 4, 2 and 8 into 1, 2, 4, 5, 8. Insertion sort works just like arranging playing cards in your hand. You pick up the cards one by one, and each new card you slide into its correct spot among the cards you are already holding. Everything you've placed so far stays sorted at all times. Here is the idea. We think of the front of the list as a sorted hand, starting with just the first element. Then we take the next value, call it the key, and slide it leftwards, stepping over every value that is bigger than it until it finds the spot where it belongs. We drop it there. The invariant is that after each step, the whole front section stays perfectly sorted, and it grows by one element every time. When the last value has been inserted, the entire list is sorted. Starting from the second element, we lift out the current value into a variable called key. Then we look leftwards with index j. While there are still elements to the left and they are bigger than the key, we shift each one right by one spot to open up room. When we stop, we have found the gap, so we drop the key into it. After the loop, the list is sorted. Let's build it live and watch each value slide left into its rightful place. From the second element on, we lift the current value into a key and look at the slot just left of it. While the elements to the left are bigger than the key, we slide each one right to make room. We drop the key into the gap we opened, and once every value is inserted, we return the sorted list. Now let's test it and hit run. And there it is. 5, 1, 4, 2, 8 sorts into 1, 2, 4, 5, 8, each value slotted neatly into the growing sorted front. Here's the flow. We take each element as the key, then look left. While the left values are bigger than the key, we shift them right, one at a time. When we stop, we drop the key into the gap and move to the next element until the list is done. What is the cost? In the worst case, a list sorted backwards, each new value has to slide past everything before it, so the work grows like n times n, order n squared time. But on a nearly sorted list, it is close to linear, which makes it lovely for almost sorted data. It sorts in place, so order one space. 3 things to watch. First, the while condition needs both parts. Stop if you run off the left end, and stop once the left value is no longer bigger than the key. Second, shift the bigger values right before you write the key so you do not overwrite anything. And third, the key belongs at j plus 1, the gap you just opened up.